The goal of this video is to write equations of sinusoidal functions. So I'm going to go through some tips and tricks on writing equations of sinusoidal functions. All sinusoidal functions can be modeled by an equation that looks like this. Y or f of x equals a, and we've talked about the rules of a, k, d, and c in this equation and how it transforms graphs and how all of them are similar in their wave-like structure but different if shifted one way or the other, or stretched or compressed or flipped upside down. The other, we can also use this equation, which is, say, y could be an a, but also times cosine of k times x minus d with these same values. Both are called sinusoidal functions, and in all cases, every time we write, say, a function that has that equation, we could also write one that has a cosine equation. Okay, and we can always do one or the other, and sometimes it'll be easier to write sine or cosine depending on how the function looks, and I'll go through some of those tips today. So let's kind of dive right into coming up with an equation for a particular graph. Okay, so the first example is we'll be looking at graphs, and that's kind of the goal for our video here, is to look at a graph and write an equation to model that graph. Let's look at this one. So I have this graph here. I've got this sinusoidal function here. I want an equation for it, and I'm going to write an equation that models the one that we did before, or the one that we just saw on the last slide. So we're going to say we'll need to determine all those values. If we can determine all those values, we can write the equation. So I'm looking for values for a, k, c, and d. Something you're going to want to take notes on is there are some special equations that I use to help determine the a and the k and the c and the d, namely from those definitions of what those equations are, or those values represent. The first one is the amplitude of a graph or a function. The amplitude we've talked about is also the a value. Okay, so this is going to help calculate the a value. The amplitude is how much it's stretched or compressed from its original form. And the amplitude is also defined to be the distance, say, from the axis to the maximum. Or one way to look at it is it's half the distance between the maximum and the minimum. And that's where this equation comes in. So if I can determine the amplitude from this equation, I've got the a value. So this is going to determine my a. The other equation that we're going to look at that we need to help determine the k and the c and the d is this one here, the axis of symmetry, okay, which is like a horizontal line that cuts it in two. So what we'll look at is this is always halfway between those max and min. So if I take the max and add the min divided by 2, that's like the average between the max and the min. It's halfway between. Now this is going to be my last value there. This is going to calculate my c, whether the whole thing is shifted up or shifted down, because the axis would be shifted up or shifted down. The last equation that we use is the equation for the period. If I know the period, and usually we can determine that from a graph by counting how long a cycle occurs, I can calculate the k value by solving this for k. So an alternative solution or an alternative form of this equation is that the k value is 2 pi divided by the period. And that's because when we talk about our stretching and compressing, if k is a whole number, we would divide by that k, and that's like taking the period and dividing it by k. It's going to, say, shrink it down if k was bigger than 1. So it'll cut my period down. So we use these to help determine the a, c, and the k value, and the d value, the shift left or right, all depends on whether we're going to use sine or cosine to model this. So let's go back and look at this. I always start with finding the amplitude, and over here I will just do these calculations. Okay, so my goal here is to, say, write an equation like this, a, and then sine or cosine of a k times an x minus a d plus a c. Okay, So the A is going to be calculated this way. I'm going to take the maximum. So the maximum is here, which has a value of 3. Okay, so the maximum is always the y value. So it's the maximum, which is 3, and I'm going to subtract the minimum. Minimum's down here. It looks like it's negative 3. So I'll subtract negative 3. I'll divide that by 2. 3 subtract negative 3 is 6 divided by 2 is 3. So our A in our equation is a 3. The amplitude is 3. Okay, so for the axis, we'll add those together and divide by 2. So I'm going to take the max, which we know is 3, and I'm going to add negative 3, and I'll divide that by 2, and when I do that I get 0. So this one doesn't have a shift up or down. You can see that from the graph that the axis is right on 0. It's not been moved up or down. Lastly, I'm going to find the k. In order to find the k, we're going to take 2 pi and we'll divide it by the period, which we can read from a graph. So I'm looking for the length of one cycle. Tips on that is, what's the length between the two maxes? Or what's the length between the two mins? Or find an x-intercept and follow the cycle until it repeats. What would be that length? They're all going to be the identical length because of how these are periodic functions. So most times we can count, or we have to subtract. So from here, this is 0 through pi, so that's the distance of pi. So this period is pi. So the k is 2 pi divided by pi is 2. This has a horizontal compression by a factor of, you could say it's being compressed by a factor of 2, like cut by 2, or it's say compressed by sometimes we can say it's compressed by a factor of a half. It's cut in half. Okay, so knowing all this information, I can plug in almost everything. I can plug in my A, which is a 3, and I can write sine if I'm going to use sine, and I know my k. And then I'm going to put x minus, and I'm just going to leave it blank for now because I haven't determined d, and I'll put plus the c, which I've determined to be 0, which we're just not going to write. So at this point we're going to determine the d. If I'm choosing to use sine, then I have to use one main property of sine. The main property of sine that we need to use is looking at where the maximum of sine normally would occur. The maximum of just sine, like sine x, normally occurs when x is pi over 2. Okay, that's our 90-degree marker, pi over 2. Okay, so normally its max occurs at pi over 2. So if I can determine where the max is, I can then determine how much has been shifted to the left or right. In determining that d value, using this idea where the maximum of sine occurs at pi over 2, we have to, if the maximum of sine occurs at pi over 2, ours is got a 2 in there, okay, so it's already been compressed by a factor of 2. So we would divide its normal maximum first by that pi over 2, or by that when it's pi over 2, we divide that by that 2. So if I divide pi over 2 by 2, I get pi over 4. So sine of, say, 2x is supposed to have a maximum at pi over 4. Pi over 4 is here. So sine of like a compressed sine is supposed to be there if there's no shift. Okay, so it's supposed to kind of come up if there's no shift and come down and look like that, but ours doesn't do that. Okay, so ours has a different spot of where that maximum is. So if I put that, that's supposed to be at pi over 4, the maximum. Ours is back here. Okay, so ours has been shifted from its original position back that distance to that spot right there. So we have to say determine that distance. Now since this is the y-axis, it's been shifted from pi over 4 back to 0. So it's been shifted to the left by pi over 4. So that is our shift. So I'm going to put it's shifted to the left, so it's a positive in here by pi over 4. And that is our graph, our equation of this particular function.